Success is a process, not an event. So don't settle. Let's take 10 more steps. In this 10 Kadam series, part 1, we will discuss 10 illustrations of rotational motion. Consider a two-particle system with particles having mass m1 and m2. If the first particle is pushed toward the center of the mass through a distance d, by what distance should the second particle be moved so as to keep the center of mass at the same position? अब देखो मैं कहता हूँ दो पार्टिकल है m1 m2, दोनों कुछ डिस्टेंस पर रखें और यहाँ पे सपोज सेंटर ऑफ मास है. इफ द फर्स्ट पार्टिकल इज पुश टुवर्ड द सेंटर ऑफ मास, फर्स्ट पार्टिकल को आपने सेंटर ऑफ मास की तरफ पुश किया बाय ए डिस्टेंस d, देन बाय व्हाट डिस्टेंस शुड द सेकंड पार्टिकल बी मूव्ड so as to keep the center of mass at the same point? We all know RCM is given by m1 r1 plus m2 r2 upon m1 plus m2. So delta RCM is written as m1 r1, so m1 delta r1 we can write in vector also, plus m2 delta r2 upon m1 plus m2. So delta RCM is 0, so this factor is going to 0. So ultimately what we are getting m1 delta r1 equal to minus m2 delta r2. So it is visible to all of you, if m1 is moving toward the right side, m2 must move toward the left side. So what is the displacement of the second particle, that is the delta r2, that we have to calculate? It is given by m1 delta r1 upon m2, negative only direction that I have marked. So it is given by m1 by m2, and what is the delta r1? That is d. So we will say option D is the correct answer of this problem.